First things first, if you have a right triangle, the first thing you need to do is recognize that it's a right triangle because it has a right angle, and recognize that the side across from it is the hypotenuse, exactly. Okay? Now, a couple of ways that you could be asked a question about this. Right? If I give you two sides and ask you to give me the third side, that's a Pythagorean theorem problem. And it doesn't matter what the numbers are. The hypotenuse is always C. The other two legs are A and B. It doesn't matter which is which. And what we know is that if it's a right triangle, A squared plus B squared is equal to C squared. This part, the one on this side, the one by itself, is always the hypotenuse. So if I gave you this side and asked you for that side, you'd have to fill in this number and then do the arithmetic to find that number. The other thing that you need to know about the Pythagorean theorem is the converse, which is if you have a triangle, and you don't know whether it's a right triangle or not, but you know the side lengths, check it out. If A squared plus B squared is equal to C squared, that means it is a right triangle. So this is a test that works both ways. If it's a right triangle, this is true, and if this is true, it's a right triangle. That's what happens if I give you two sides and ask for a third side. If I give you one side and one angle, and I ask you for second side, that's a trigonometry problem. So the first thing you have to be able to do, in addition to being able to identify the hypotenuse, is you have to know that if this is the angle that you're looking at, and somebody has given you the degree measure of that angle, and theta is the variable we use for angles usually.
So I can say
If you sit at the table here and look across the table at the person sitting across from you, that person is opposite you.
sine 15.
If there's a person sitting here, that person is next to you. That person is adjacent to you. Adjacent means next to. You need to be able to identify which side is the opposite side, which side is the adjacent side, and which side is the hypotenuse. It all depends on the angle. If you were sitting at this side of the table, then this would be opposite, and this would be adjacent. So wherever the angle is, that's what you need to be working with.
So AAS, right?
There are three trig functions that we use.
And S.
One of them is called the sine, one of them is called the cosine, and one of them is called the tangent. When you say, well, how do I know which one to use? It depends on what you have. Remember, I said I'm going to give you one side and ask you for another side. So you look at the two of them and you say, well, what two do I have? If you have the opposite and the hypotenuse,
The answer is
it goes there. If it's the adjacent and the hypotenuse, then it's cosine. Tangent,
Yes.
opposite over adjacent.
yeah.
What does that mean? That means
Let me come back to that one.
you're going to have to find out what number this is. If I give you the degrees, right? Sort of like a code. This is a number. This is a number. This is a number.
2.
But it's in code.
Okay. So
And in order to crack the code, you either have to have a trig chart or you have to have a calculator.
A.
No other way to do it. Okay? Now, whatever number this is, and whatever numbers these are, it's always going to look like some number is equal to some number
68.
over some number. Always going to look like that.
How would I find this?
The only thing that's going to be different, if I've given you one side and one angle, is whether or not it's on the top or the bottom.
Sine A is over.
Okay? If you have
Oh, you're saying law of sine then?
this, and you have this,
Sine of,
and you're looking for this,
For X.
you multiply A times B, and that will tell you what you got.
X.
but which one are we
Okay.
trying to find though?
If you have it the other way,
So we have to do something
A
first.
is equal to B over X,
Find angle C, right?
then you got to swap these.
Is it sine of
X
44
is equal to
versus
B over
sine of
A,
81 over C?
and every fraction is a division problem. So you're going to take this number
Sine of
and divide it by
44
this
versus
number.
BA is equal to sine of 81 over C.
And that will give you your answer. Okay? So it's foolproof.
Sine of what?
81.
You look at the triangle,
Yeah, over
identify opposite, adjacent, hypotenuse,
C.
figure out which side is being given to you and which side is being asked of you.
Any questions on how you got 81?
Figure out which of these three has the pieces that you have, plug them in, do the arithmetic.
Triangle that is
End of
180
story.
degrees. So if you know these two,
Now,
that makes sense?
the trig chart has a list of angle measurements and then sine, cosine, and tangent columns. So if you're looking for,
C,
right, whatever you're looking for, whatever number you're looking for, you just find it and go across here to find whichever number you want.
68,
If you're dealing with a calculator, they got buttons on them that say sine, cosine, tangent. And the thing with the calculator is you don't have to do it as two separate problems. If I had, for example, let's say I have this problem.
good so far?
Here's theta, here's this. Let's give this a number. Let's say this is 23 degrees.
Yeah.
Okay? Let's say this is 15. And let's say we're looking for this.
What's my last step?
What kind of problem is that? Sine, cosine, or tangent?
Remember, we're trying to find C, right?
Yeah.
Right.
So
It's a sine problem. So sine of 23 degrees is equal to the opposite. In this situation, you're going to multiply 15 times the sine of 23,
get it back.
and that's going to be equal to x.
What part is
So
confusing?
what do?
This
23. Right, if you have this kind of calculator, it's
C.
backwards. So anyway, you get the sine of 23 degrees, multiply it by 15,
Oh, okay.
and you're done.
Yeah.
The answer to this is 5.9 or 5.860966927 ... These are irrational numbers. They go on forever and ever and ever. They give you an angle and a side, ask for another side. That's a trig problem. You're given the adjacent and ask for the hypotenuse. So the cosine of 61 degrees is equal to the adjacent over the hypotenuse. For this kind of problem, you got to swap like that. And then it's a question of just putting it into the calculator and saying 14 divided by the cosine of 61 degrees. And it's 28.87 or 28.9 rounded to the nearest tenth. So that's the answer to that. Another thing that can happen is I could give you two sides,
Your angle, right? Doesn't matter what it
and ask you to find an angle,
Remember, the hypotenuse is always opposite of your right angle, right?
okay? That's an inverse trigonometry problem.
And it changes. Like, what if my
And what that means is, instead of knowing what this is and using it to solve the equation, you'll get these two numbers over here
what would be my adjacent?
and use the chart backwards or use a different button on the calculator to find out what angle has that tangent, cosine, or sine.
Okay. So no matter where it is, you just have to reference.
So, for example,
That's all you gotta do.
right, if I said, I don't know, if I gave you two sides, like 3 and 5, and 5 is the hypotenuse, and 3 is the adjacent side, that would make this a cosine problem. You would have to turn this into a decimal, then find the cosine, look down until you found the closest number to 0.6, go across, and that's going to be your answer. Okay. Let's say this is 8 and this is 7, and I want to know this angle. Okay. First of all, this is the hypotenuse. Which one is the opposite?
8.
Right. This is the opposite.
I get confused. Why do sometimes
This
you
is the
divide,
adjacent.
sometimes you multiply?
Depends.
Okay.
So let's compare. it
So
to
I have the adjacent and the opposite. Of the 3 of these, which one is that going to be? The tangent, exactly. So we just write this down. The tangent of theta degrees
Cosine, right?
is equal to the opposite over the adjacent. Okay.
What's cosine?
So now, first of all,
Adjacent or-
let me find out,
So
right? 8 divided by
what's the
7.
difference between this
It's that number,
and this?
okay? 1.142 something, something, something.
So when it's in the
So
numerator,
that's what's
you
here.
don't need to move.
I don't have to
You have to move
write it down necessarily,
the number, right?
because what I really want
You just have to multiply
is
both.
I want to know what theta is.
Wow.
So if I had something like this, 7 plus 3, no, 7 plus blank
I just have
is
a
equal to
fraction
10,
trivial, so I would rather do
it looks like an addition problem, but it's really a subtraction problem. You have to do the inverse
So there's
operation,
a trick to this.
right? You guys know all of
Factors
this.
in the numerator?
Multiply.
If I want this looks like a tangent problem, but it's really an inverse tangent problem, because what I want to find out
We good.
is what
What's the answer to
angle
this one? I don't know what it was.
has a tangent
See,
It was C. C?
of this. Yes, ma'am. Where did I get what?
We good?
Yeah.
Where did I get the 10 from? I made this up. I was just showing this as an example. Okay? If I said 7 plus blank is equal to 10, it looks like an addition problem, but it's really a subtraction problem. This looks like a trigonometry problem, but it's really an inverse trigonometry problem, because you have this side, you want this side.
Let's do that then.
This is the symbol for rewriting that. It says that theta is equal to whatever angle has a tangent of this number. So now, here, I have that number in the calculator. Right there, if you look carefully, you can
Any
see
other questions you guys want me to go over?
tangent,
Besides that?
inverse tangent,
not in this package.
right here,
Not that one?
okay? Which means you have to first touch the shift button here, and then the inverse tangent button here,
So 5, 7,
and what pops up
and 6,
is 48.8.
8.
So this angle is 49 degrees, okay? Approximately, because I rounded to the nearest degree. That's what an inverse tangent problem looks like, and you have to be able to do one of those as well. So what I've just shown you is that for an inverse trig problem, this is an example,
That's right.
right?
The shorter route.
And for example, the tangent of theta is equal to A over B, where you know both of these numbers.
So,
So what you have to do is take theta, because that's what you're looking for,
doesn't matter if this is A or B, but we know that this one is
C.
and use the inverse tangent. To get that. And that either means pushing this button on the calculator
400.
or turning this into a decimal and using the chart backwards so that you look down the column until you find the number that you're looking for and then go across and find what angle it is. You won't find the exact number, but whatever is closest, that's good enough. Any questions about that? Okay.
But that's not the answer.
So we've got right triangles. Two sides ask for the third side. A side and an angle ask for the second side. Two sides ask for an angle. You notice that in each one of these cases, I have to give you two things and ask you to find the third thing.
Because he went to Ferris.
There
and
are
back to Bud,
some
and that's
cases
35.
that are special,
Just from Ferris to
where
Bud,
I can give
25,
you
so that's
one
how
thing.
short is it?
Perfect.
By 10.
by 10. Very good.
and ask you to find the two other sides. Okay?
Right?
That can only happen with special right triangles.
Five.
A lot of you
So
will look
say,
at these
how
triangles
short
and say,
is
oh,
it?
well, that must be
When you
30,
went to
60,
the
90.
before instead of straight to
You
Ferris.
don't know that unless it says so.
25.
Okay?
There you go.
So if I give you this, that's not a 30, 60, 90 triangle.
Yes.
Okay, so.
If I put a
from
30
here
in
to
here somewhere
Right?
and a right
Now,
angle,
so you
now
have to
it's
think of
30,
the
60,
full trip,
90.
Right?
So you don't use special right triangles to find stuff
How
out
much shorter is it?
unless you
Just go
already know somehow that it is one.
Right? This.
It's not something you can just pull out of your hat.
That direct. Route. Does that make sense?
The two different kinds are 30, 60, 90,
No,
or 45,
it
C
is
is
25.
45,
The answer is 2.
90. Two different kinds of
This entire
triangles.
trip took what?
One is 45, 45, 90.
The direct route.
If
takes
it's
how
45,
long?
45, 90, it means it's an isosceles right triangle.
So what
This
would be the
angle is
shortest
45
route?
degrees, and this angle is 45 degrees. And if it's an isosceles right triangle, then this means
miles shorter.
this is a leg, this is a leg, right?
So then
And
there's
this is the hypotenuse. But it means that whatever this number is, this is going to be the same, and then you're going to use it
But Adam doesn't.
to find this one, or the vice versa.
That's what the question
You really don't
I can either give you the leg, or I can give you the
15 minutes to
hypotenuse.
get here. The
Right?
short
If I give you the leg,
takes just 25 miles.
the hypotenuse
The
is
shortest route
that
would be
number
this minus
times the square root of
the
2.
25, the direct one. Does that make sense? Yeah, sure. Okay. All right.
If I give you the hypotenuse, then the leg is that number times the square root of 2 over 2.
Do you want to write the one that you want to write here on the side?
Do it.
And work on
And if you know one leg,
because it feels like
you know
we
the
get
other?
this part. We get this.
and if you know the leg, you get the
I don't
hypotenuse.
think I explained it.
The other kind is 30, 60, 90. You only have a 30, 60, 90 triangle if you already know that you have 30 degrees, 60 degrees, and 90 degrees as your angle.
For a angle,
One thing about a triangle,
you're supposed to use
if you can find what angles are small, medium, and large, that tells you what sides are small, medium, and large.
so
Across from the smallest angle, you have the smallest side. Across from this one, you have one that's larger.
tangent, right, tangent.
And I'm not using largest because that's always going to be the hypotenuse. The hypotenuse is always going to be the largest side. So those are the three different sides. You've got a short leg here and a long leg here. And you'll notice that it's not how I drew it.
True.
I didn't draw it to scale. I drew it freehand. And this looks like it might actually be longer than this, but it doesn't matter because if this is 30 degrees and this is 60 degrees, this is the short leg, that's the long leg. That's a problem that I can give you in 3 ways. Right? I can give you the short leg,
That makes sense.
the long leg,
And my
or the hypotenuse.
because it's divided.
If I give you the short leg, the hypotenuse is twice as long. So you multiply it by 2. And the long leg is that number times the square root of 3.
C6 is what you got? Okay.
Why do you divide it by 1? I think that's just the answer.
If I give you the hypotenuse, well, we already know that this is twice as big as this, so that means I got to take this and divide it in half.
4 pi times 7, you get 28 pi.
And I already know that if I know this number, I have to multiply it by the square root of 3.
Inverse of C up here.
Say again? That's if the hypotenuse is given, right. So then this would be x over 2 times the square root of 3. Finally, I could give you the long leg.
We all good?
Oh yeah, so I guess
If I did that,
this one too.
the short leg is that number
Each other,
times the square root of 3 over 3,
4 times pi.
and the hypotenuse is twice as big as that. So it would be that number times 2
You would get 30
times the square root of 3 over 3.
and 3. Just like, so when you
I believe that that is everything you need to know in order to pass this standard.